recording again. And I just mentioned that the gain is defined as this quantity. And when we look at the, the, the dimensions, 1 over centimeter, then I did remark that, this is just like this part. It's just like A, the attenuation constant. Okay? So what is this? What is the physical meaning of G? Let's just look at that for a moment. Physical meaning of G. Okay, and I think it's best brought out, best illustrated for weak excitation. Okay. For the case of weak excitation. So, and what we had was, there's this medium, Z, and let's say we have a beam coming in, right? And weak excitation, why did I say that? Well, that enables me to say that most of the atoms are in the ground state. So N1 is about equal to N, and N2 in the excited state is about equal to 0. Okay, and in that case, the gain, you notice, which was defined as N2 minus N1 sigma, becomes minus N sigma. Haha. And now, doesn't that remind, where else have I seen this minus N sigma? So this reminds me, here it is, right? N sigma. In fact, there's Beer's law, minus N sigma Z, right? A with the minus N. So this reminds me of Beer's law. And what was Beer's law? Beer's law said the intensity at Z is the intensity naught e to the minus a Z, right? And A is N sigma Z. Okay? So exponential attenuation, because most of the atoms are in the ground state, they're all absorbing, there's exponential attenuation. Okay? Now, what this means is that if, so this is where the physical meaning of G becomes clear, that if you can make this guy here, the G as it's defined, if you can make G greater than 0, and when would that be greater than 0? That would be when, when is G greater than 0? When there is a population inversion, N2 is greater than N1. But if G is greater than 0, then Beer's law becomes intensity of Z, I naught, and it's a e to the GZ, where G is positive. You see? So now there is gain. This is where you actually have gain. And your intensity exponentially grows because of lasing. Okay, so that's the physical meaning of this. That if you can arrange this to be greater than 0, then that's the quantity right there that is giving you exponential gain. Okay, so does this connection make clear why we call this gain and why it's so important to have gain greater than 0 for lasing? Okay, so actually we've arrived at a condition that you need a population inversion. Okay, so N2 must be greater than N1 for lasing. Okay, so that's an important thing. In fact, the whole exercise in the lasing industry is to achieve this. If you can achieve this, you have a laser. And if your material does not allow you to pack more atoms into the excited state than the ground state, you simply can't achieve lasing. Now, next time, we're done today, but next time I will show you why you cannot, like no matter what material you use, you cannot make a laser with a two-level atom, because it turns out that the harder you pump and try to get atoms up into the excited state, that same pump causes stimulated emission back at the same rate. So you can never, the best you can do is have half and half. Okay, 50% atoms in the ground state, 50% in the excited state, and so you never have an inversion. You can eke your way up to zero, they're equal, but never more than the ground state. So you're kind of stuck. And so then there are these ingenious schemes for how does having one extra level, a three-level atom, how does that enable you to achieve lasing? And it's all about playing with this inversion. Three levels allow you to manipulate this inversion. In fact, I can, and this is my last 30 seconds for today's lecture, that in this expression for the inversion, the three-level atom allows you to make this N2 larger than N1. You can boost this up. And in the four-level atom, not only can you boost this up, you can take this N1 and push it down. So the four-level atom allows you to do a double whammy on this. You push this up and push that down. Three-level atom, you can push this up. That you can't do much about. Okay, so so this is the beginning of, we've even written down a simple rate equation. It will be more of the same for three levels. But first we will see why this can never lead to lasing. It's simple. But these are very simple equations, and they go a long way there. Okay, I guess that's all I had for the material. I am more than happy to linger on for a few minutes, and if anyone has any questions or just shoot the breeze about academic life right now. I wonder how everyone's courses are going, all the other courses. But about this course, I'm waiting for Kifan to send me videos of the next thing in the lab. And oh, by the way, I have to show you my t-shirt. Oh no, well, this t-shirt is not so, it's just me and my atom trap. You've seen this before. But there is a t-shirt I will wear for when we get to the frequency narrowing of the laser lab, because it uses a diffraction grating, and how that diffraction grating works, it's shown on a t-shirt that I have. I thought I was wearing that one. I don't know when I changed into this. So I'm going to shut up now, and any questions, I'll just hang around for a few minutes.
So the reason a two-level atom won't lase is stimulated emission keeps forcing the excited atoms back to the ground state?
Yeah, at the same rate as they're getting absorbed back up.
Okay.
Yeah, that's effectively it's a very good qualitative answer. That is what happens. Exactly.
I actually have a question about quiz 9, if that's okay.
Oh yeah, sure. You may have to remind me what it was about. But...
Yeah, on the first question, you ask what are the dimensions for the gain coefficient as introduced in the differential equation, and I'm not sure what you mean by dimensions. I don't remember us talking about that.
So dimensions just means, what is it, 1 over length, 1 over this or that. Now, you notice that here we've properly defined the gain coefficient and all with its proper units. But and I believe I'm talking about this equation here in the cartoon model. So Yeah, I mean, I'm asking for the dimensions of this A, this gain coefficient. So just by looking at the equation, you can, yeah, I mean, basically it's like, for example, the dimensions of of a volume are length cube or a meter cube. That's
Okay.
that's what I'm looking for. Or velocity is meter per second, so things like that. Does that answer the question?
I think so.
Yeah, I mean, so the way it was introduced here, this is not going to be like, I mean, in idea, it is the same as this gain coefficient, but they're not the same. I mean, okay, this is the correct, precise definition. This was just thrown in there to, um, bring out the idea that there are things like threshold and stuff like that.
Okay.
And was the third question in quiz 9 clear to everyone? Was it quiz 9 or quiz 8 where I'm sort of banging on a little bit about explain in your own words and don't just write out. I think it was something about don't just write out this equation the way, I mean, like I've written it out in English, but don't just write that out. Explain what threshold, the explain the condition or something. Like I hope that's clear to everybody. I'm not asking for like a lot of information or something. I'm just asking for um, just something in your own words which describes clearly. And I wish I remember exactly what the question is, but that you know describes clearly why there is a threshold or something like that.
Is this video going to be posted today?
Yeah, the thing is that there's always a bit of a delay because I have to convert it to a YouTube thing.
Yeah.
And those files take a little while to. So sometimes, I mean, it's not until night that it all gets finished. Meaning it doesn't take that long, but it's just that, um, yeah, I mean, so that's what. Oh, and so that's why I'm trying that. Whenever I ask a quiz, so I'm gonna have the quizzes always. I'll try my best to have the quizzes always due Tuesday and Thursday. Like, I mean, uh, is that good or like? I mean, it doesn't matter to me. Like, I can pick other days. Like, I can have Friday or something. Um, it's just that like right now it seems like people are having trouble following deadlines because there are too many deadlines. There's a quiz due then, not now, and then that, and that's only because of this WebEx thing. Like um, uh, I don't know how else. Like, I mean, every time I make a lecture, then I have some questions and a quiz on it. So every lecture comes with a quiz, and it the quizzes are easy, but they're people need some time to do them, and I don't know is couple days enough or whatever. But they'll be due Tuesday, Thursday, and then there'll be a lab quiz every now and then, which will, that's another thing which will pop up. But other than that, there are no other deadlines except for the presentations finally. And so I don't really have much of a feel for how people are hanging in there on this. All I see is that sometimes, I mean, and I know that it's not that people are just blowing me off or anything. It's just that there's so much stuff happening on that one computer, and then the instructors are sending emails, and I mean, even from one instructor like myself, there's emails, and then there's texts, and then there's this and that. So stuff keeps getting missed every now and then, and I understand that. I just don't know what the most effective way is to get people to observe the deadlines. I mean, it's not a lot of work. It's just that it's a bit of work staying on top of all the incoming, on the computer.
I think the biggest thing is like just having consistent deadlines. Because I
Yeah,
think the first
yeah,
couple weeks the quiz deadlines moved around a bit. So like
yeah.
there was Tuesday and Thursday and Saturday, and then another Tuesday, then a Wednesday. Then like they've shifted enough that we couldn't get into a routine of like this is all the things I have to do every Thursday.
Yeah.
This is all the things that have to be done by every Tuesday. If you pick Tuesday and Thursday and stick with it,
Yes.
then I feel like it'll be easier for us to keep up with
Okay.
when are there quizzes.
Yeah, and I was very I was realizing that at all times, like yeah. So yeah, so this is a reasonable thing to try out for a little while, Tuesday and Thursday, and the lab quiz will pop up as soon as Kifeng can get good stuff done, and so we'll try this out. And once again, don't feel bad if you miss some deadline or so. I'm totally happy to work with you, and I will wait till you send it in. But yeah, I mean there's a finite time limit, Like I mean, yeah. So I'm gonna get to work posting these videos, and at this point, I guess anyone who wants to leave can leave. And I mean, are there other questions that someone might want to ask, or I can leave the thing on for a little while, and if someone wants to talk, we can talk. Otherwise, feel free to leave also. I'll just start working on posting the videos. First of all, with my heart in my mouth, I have to go and see if the video is actually recorded, which is always, it's always like a relief when you see them there. So that's one thing I'm going to go do. Okay, so I'm going to... Yeah.
I have a question. So
yes.
I submitted the quiz 9 yesterday. So but today, since you talked about the first question, so can I resubmit it after I change my answer?
Absolutely.
Okay.
Absolutely. Not a problem at all. Just fire off a 3-word email to me or something. Or just send me an email saying that we decided to do this, so I remember.
So send you the email with the corrected quiz, right?
Yeah, and you can also send me that. But before that, just send me an email saying that, hey, ignore my first quiz, and I'll send you a corrected one in a moment or later or something.
Okay.
You want quizzes submitted through Canvas, right? Or do you still want them emailed?
I don't know. I mean,
they are Canvas assignment, some of them.
Oh, okay. So are you saying that people have been submitting stuff on Canvas and I was clueless about it? Is that what happened?
I don't know. I submitted my quiz 8 as a file upload on Canvas because it had an option for
that's what
file
I was wondering. Like, well, how come? Like, I mean, okay, so that makes a lot of sense. I never looked in there because I'm a neophyte and I didn't know. I will definitely check that out. So maybe I've been going all nervous about this, and there was no need to.